Welcome to another episode of the Energy Central Power Perspectives podcast, where we speak to the changemakers driving innovation across the energy sector. Today, we're taking our conversation above and beyond, literally, because while Earth-based grids are undergoing transformation, an entirely new kind of infrastructure challenge is emerging overhead. How do we power the growing number of satellites and spacecrafts operating in orbit? Satellites today are shrinking in size but expanding in functionality, and their missions are increasingly constrained by a simple truth: don't have enough power to do it all. And that's where today's guest comes in. Joining us is Andrew Rush, co-founder and CEO of Starcatcher, a startup building the first true power grid in space. Andrew and his team are on a mission to solve the energy bottleneck that's holding back the next wave of innovation in orbit. Matt, help us understand from the Energy Central community what the discussions have been like in space-related questions from your observation.
Yeah, it's a really interesting moment to be having this discussion because, while the Energy Central community, it's very much grounded literally in utilities, transmission, earthbound infrastructure, we are starting to see space technology pop up more frequently in related conversations. So opportunities like space-based climate modeling, satellite-supported GIS tools and grid resilience strategies, or even emerging ideas like beaming energy from space to the ground. These are all topics that our members are recognizing that, what's happening in orbit, it's increasingly relevant to what's happening down on Earth and on the grid. So maybe a few years ago, those conversations, when they came up, they felt a little bit more like science fiction. But I think that curiosity is blossoming before our eyes into some real strategies, some real discussions about how thinking bigger about space can help our traditional and modern terrestrial energy challenges. So, that's all to say. Space isn't necessarily a daily topic on EnergyCentral.com's platform quite yet, but the interest is growing. And I think today's episode of the podcast will feed into that and maybe be a Kickstarter to some more interest.
I would agree. All right. Well, thank you, Matt. Thank you for that. And before we dive in, a big thank you to West Monroe, our sponsor of today's episode. Now let's get started. Andrew Rush, welcome to Power Perspectives. So let's kick things off with the founding story. All right. You've had a fascinating journey to where you are today at Starcatcher. So walk us through the origin story of the company and how this vision of space-based power grid came to life.
Myself and one of my two co-founders at Starcatcher, Mike Snyder, have been working together for about 10 years. And this is actually our third space company that we've built or scaled. The first company that we built was called Made in Space, which is a very kind of sci-fi to science reality company. We were the first folks to manufacture functional objects off the face of the planet with 3D printing. We built that company up and sold it in 2020. And then we went on to become the founding president and chief technology officer, respectively, of Redwire Space, which is a diversified subsystems and components manufacturer for the space sector. So we've been involved in a lot of different space missions. And in those space missions, we always ran into swap constraints, size, weight, and power. Now, over the last 5 or 10 years, the aperture around size and weight has really opened up because of the advent of reusable rockets and that lowering the cost of operations, lowering the cost to get to space. But we're still doing power in the same way we've always done it. We go out in space. We go on these little camping trips. We take our solar panels with us. They're a finite size, and you're really trying to size that to, the balance between cost and mass available and volume available to operate in space, which was okay in the past. But now we have all of these ambitions, all these needs for our spacecraft that we want to do direct-to-cell connectivity. We want to do edge computing in space. We want to do high-power remote sensing. All of these things require a lot more power than traditionally has been available on spacecraft. That coupled with kind of looking at how we do things on the ground, we have fundamental infrastructure everywhere, roads, power, and comms. And in space, our roads are rockets. Our comms are big dishes that talk to satellites, but there hasn't really been an orbital energy grid to provide that same kind of infrastructure for satellites and enable them to operate in much the same way we operate things on the ground from a power perspective. And so that's why Starcatcher was founded, to build the world's first orbital energy grid.
That's great. So, Starcatcher is a technology play. So let's dig into the technology. There's been a lot of discussion around space-based solar power for Earth, beaming down from orbit. But your team has taken a different path, focusing on beaming power within space. So break that down for us. How does Starcatcher's solution work?
Yeah, no, it's a great question. So we have a couple of fundamental principles for how we're building our orbital energy grid in order to maximize the use to spacecraft that are already flying and spacecraft that are under development today. So first of all, we're focused on space-to-space power beaming because we fundamentally want to take kind of a crawl, walk, run approach to developing new technologies and services. I've been reading science fiction since I could read, and the promise and potential of beaming power from space down to the ground is awesome. But we don't really think it's quite there yet from a technological and regulatory perspective. But beaming energy to other satellites to give them more power, higher concentrations of power, even power eclipse, we think now is the time. And so what we are doing is building in a constellation of satellites that will orbit at kind of the top of low Earth orbit, which is where most spacecraft are in space today, that will collect energy from the sun, condition that energy, and transmit it on to our client satellites that we track with onboard optical tracking systems. And we send that energy not to a custom receiver, which would require a money and mass investment by our clients and constrain who we could send energy to. But we send energy in the kind of 400 to 1100 nanometer regime, which is basically visible in near infrared light, to our clients' existing solar arrays so that we can give them that additional power. This is really important because it avoids the chicken and the egg problem of them needing an interface, needing a custom receiver to work with us. And the other really awesome thing about this that many of your listeners may already know is that a solar panel is a bunch of photovoltaics, and photovoltaics, if you send them more flux, if you send them a higher intensity of light, they generate in a roughly linear fashion more power. So in space, we get 1,300 watts per square meter of energy from the sun, and we generate maybe 400 watts per square meter with our solar arrays. If we, increase that by 5 times, we actually can generate not 400, but 2,000 watts per square meter, and really increase the amount of power available to that spacecraft. And this is the way that we can take a small spacecraft with a really high power, awesome payload that maybe with just the one naked sun is getting 10% uptime. It's got to charge batteries and then discharge and then do that cycle over and over again. We can take that spacecraft from 10% uptime to 50% to 100% uptime, dramatically increasing its usability and the ROI that the satellite operator can get.
This transfer of the technology, which I think is really key here, is very interesting, but it's also, listeners will think it sounds science fiction. So talk us about the progress. Where does the project stand today? Do you have a proof of concept? And what does the timeline towards implementation look like?
So we announced the company a little less than a year ago, in July of 2024, that we announced the company, our vision, and the progress we've made to date, as well as that we'd raised about a $12.5 million seed round from some really well-known New York and Silicon Valley-based venture capital firms. At the time, we were about 3 folks working in a small warehouse, and had a few letters of intent from customers. Fast forward to today, we have over 30 letters of intent from a wide variety of customers. So it's literally billions of dollars of potential contract value. We have about 30 members of the team now, with 3 paying customers spanning national security, civil space, and commercial space. And we've done a series of really awesome technology demonstrations. In our laboratory, we've demonstrated the ability to acquire satellites that are orbiting in space, and then, so we can lock on them and beam power using the technology we have one day. And then we've also taken our proprietary power beaming technology to the Jacksonville Jaguars football stadium here in Jacksonville, Florida, where we're based, and set that up and beam power over the length of the football field there, which was a really cool, local thing that we did. And it was fully successful, functionally worked how we expected it to. And so the next steps going forward is taking that test from a football field length to multi-kilometer distances here on the ground, and then in next year doing that demonstration in space, and then following that up with larger spacecraft, not just demonstration spacecraft, but commercially operational spacecraft thereafter, to start doing commercial power beaming services on orbit.
Okay, I want to make sure I understood this test that you did. So in the Jacksonville football stadium, at one end of the end zone, you have your technology. On the other end, you have, say, the receiver of the power, and you were able to beam the power, transfer it without wires from one end, 100 yards to the other end. The transfer was successful. Did it capture the full power from its source to its endpoint?
Yeah, that's exactly right. So we set up our power beaming prototype on one end of the field, actually behind the end zone, and then we set up on the other end just normal off the shelf solar arrays. Some that were provided by some satellite manufacturing partners that we have, as well as some that we just bought off the shelf. We beam power to those solar arrays. It was a 105-meter distance, about 100-watt transfer.
That's fantastic. And that was the community engagement that you ran to sort of demonstrate, or was there another community engagement program that you had delivered?
We thought it would be kind of cool to do it in the Jaguar Stadium, so we reached out to them. We said, "Hey, we're a local technology company, and we'd love to do this." And they were like, "This is really neat, so come on down." And so the mascot of the Jacksonville Jaguars actually came out, which was really neat. But we also reached out to a local Boys and Girls Club chapter and had them come out and showed them, hey, this is what we're doing, and talk to them about space and the promise and potential, both to educate them, a little bit more about how awesome space is and the future and the things that they could be involved in, and also to let kids like that know, hey, this is stuff is happening, not just not down at Cape Canaveral, not over in California, whatever, but it's happening here locally. Which not everybody really realizes how geographically diverse the space sector is.
Okay, let me ask you a question here on space travel and what's going on with companies like Blue Origin and SpaceX and the investments that the government is making in all this. So there's a lot, and there's a trend and sort of this hype curve that's going on in the space. So I guess my question to you is, why now? Are you taking advantage of this curve, or are you seeing like real thoughtful decisions and investments and strategies that are going to be here long term to sustain these ongoing developments in space? So just talk to us about that, because I'm sure there's people in the audience that question whether this is just hype right now and someone's riding it, or is there genuine end game here that we can all benefit from?
That's where we've gotten companies like SpaceX and Rocket Lab and Blue Origin coming into the market and dramatically reducing the cost of launch, like from tens of thousands of dollars a kilogram to single digit thousands of dollars per kilogram to get things to space. And that has really just opened the aperture for us in the space sector to do more things in space and do those things profitably. It's also driven the shift of bringing most satellites now into low Earth orbit rather than low Earth orbit, medium Earth orbit, and even geosynchronous orbit way out, tens of thousands of kilometers away. Because of that really creates an opportunity for us to build an orbital energy grid in low Earth orbit, because for the first time, there are thousands of satellites going up to do proliferated LEO telecommunications, to do remote sensing, to do edge computing, that are all in a similar geographic place in low Earth orbit, that all ultimately could use more power to accomplish our mission. And so it's that nexus for us of a geographic concentration of customers with a common need that really drives Starcatcher and makes this a now opportunity for building orbital energy.
I want to ask you, this is a really powerful technology, especially if it comes to fruition, then its applications will be phenomenal and its implications will be monumental. Share with us, from an engineering standpoint, what are some of the big engineering hurdles that you still need to overcome to really pull this off?
So the space sector has a saying: we're willing to fly anything as long as it's flown once before. So for us, getting to an operational prototype and showing that in space we can collect, concentrate, and transmit energy to a client spacecraft's existing solar arrays and give them the energy that they want when they need it is the fundamental engineering challenge for us. We have literally dozens of customers that say, hey, if this existed today, we would use it. And here's why. Here are use cases. Here's how this would transform our business. Here's how this would transform our mission. Here's how this could save missions. But getting to that orbital prototype is really the eye of the needle for us.
I imagine my next question is pretty much along the lines of what you just answered. So what's next for Starcatcher, and what should we be watching for in the next 12 months?
We take a crawl, walk, run approach at Starcatcher. We're not just going straight to building a 100 kilowatt system in space without doing the intervening steps. So we've done our kind of mid-scale demonstration at the Jacksonville Jaguars football stadium. Our next major ground demonstration is actually going to be down at Cape Canaveral at the runway the space shuttle used to land on. It's like a 4.5 kilometer long runway. We're going to beam power down that runway, which is a really, it's a longer distance, much higher power. It's going to be a really awesome, technology proof point for us. And following that up, in 12 to 18 months time, we will do our first on orbit demonstration of power beaming.
For us Earthlings that are, energy and utility professionals and engineers and energy utility leaders, connect the dots for us. From this application, how do you see Starcatcher's technology applying here on Earth?
So there's two fundamental ways that what we're doing at Starcatcher really ties in to the terrestrial energy grid. One is that as you mentioned in your earlier remarks, there's so many different ways that we rely on space in our daily lives, right? GPS is based on satellites that are flying in space, and that's what makes Google Maps and Waze and all these things work. And the imagery in those is also from space-based assets, from satellites taking pictures of the Earth. Another way that's really interesting that we started exploring actually is the technology that we're developing and the demonstrations that we're doing, going down to the Jacksonville Jaguars stadium and beaming power linked from a football field, soon going down to Cape Canaveral and beaming at multiple kilometers. That technology could actually be used to enable drones to operate more freely and stay aloft longer and operate more freely. And so that's something we're exploring as well, and actually looking for partners to work on that commercialization with us.
Well, I really appreciate all this. It's really fascinating and certainly cutting edge, and I'm fully confident we're going to get a lot of interest from the nature of this topic. But before we let you go, and we're going to give you the final word, we do have something called the lightning round, which gives us an opportunity, Andrew, to learn a little bit more about you, the person, rather than you, the professional. So we're going to throw a set of questions at you. We ask you to keep your response to one word or phrase or sentence. If you were going into space and could only take one snack item with you, what would it be?
Pop-Tarts.
If you could get one space-related question or mystery solved, what would that be?
Probably how to practically build a Star Trek warp drive.
What's your favorite science fiction movie?
Star Trek 4.
Who have been your role models throughout your career?
My grandfather.
We've been collecting lightning round questions from past podcast guests. So this one comes from Marcus McCarthy of Siemens. How do you help those around you to be better every day? How do you help people to reach their true potential?
I think the way that we do that at Starcatcher is taking the grand vision we have and trying to break that down into digestible chunks that then we can go execute on together. So giving people the tools and the room to run in that kind of environment.
Now it's your turn. What lightning round question would you like to challenge a future guest? And of course, it can be topical and related to energy, or it can be an off-the-wall question.
I've seen a lot in the news about how AI and it is a huge power need, and it's driving us to turn on new power plants, build new power plants, et cetera, et cetera. And that really seems to have emerged in the last couple of years. I wonder what is next in that world.
Okay. And the last question, this question we ask all our guests, and that is, what are you most motivated by?
I am really personally and professionally motivated by enabling people to do more things in space and enabling them to do new things.
That's great. Thank you, Andrew. So I mentioned you get the final word. So to close out our episode, I would love for you to reflect on the multiple space tech endeavors you've been part of and shared. And what's something you've learned about innovation in this sector that you think applies broadly across industries, particularly in the energy sector back here on Earth?
So space is a really fascinating sector to work in because we as humans have had imaginations that have outstripped our capability in space for forever. right? Isaac Asimov designed geo telecommunication satellite networks before we went to space, before we had satellite. And obviously Star Trek and, had mobile phones in the 60s before we had them now. And so one of the things that I've really taken to heart and used is this notion of, having these grand visions and being inspired by what people have thought of and conceived of before us, but trying to take that and break that down into digestible chunks of product and service that we can provide, so that we can move the needle toward these grand visions that people have had for a spacefaring species.
That's great. Now, I want to thank you for, first of all, this is the first time we've had a show, and we've had about over 200 now. We've had a show where we talked about space and energy in space. So thank you for taking the time to share this with us. And again, I know that this is going to be a hot topic for our community. I want to thank you now for, really sharing us your insight and giving us a bird's eye view of what Starcatcher is doing and the great potential that could come of it. So we really want to thank you for joining us on the podcast today and sharing us your insights. Well, you can always reach Andrew through the Energy Central platform, where he welcomes your questions and comments. And I encourage everyone listening to do just that. I also want to give a shout out of thanks to the podcast sponsors that made today's episode possible. Thank you to West Monroe. West Monroe is a leading partner for the nation's largest electric, gas, and water utilities, working together to drive grid modernization, clean energy, and workforce transformation. West Monroe's comprehensive services are designed to support utilities in advancing their digital transformation, building resilient operations, securing federal funding, and providing regulatory advisory support. With a multidisciplinary team of experts, West Monroe offers a holistic approach that addresses the challenges of the grid today and provides innovative solutions for a sustainable future. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com. And we'll see you next time at the Energy Central Power Perspectives Podcast.